Hi, this is Mrs. LaBarbera. This is AP Physics Mechanics C. Today we're going to talk about conservation of energy and momentum. Here is a question from past exam. Two gliders move freely on air track with negligible friction as shown. Glider A has a mass 0.9 kilograms and glider B has a mass 0.6 kilograms. Initially, glider A moves toward glider B, which is at rest. A spring of negligible mass is attached to the right side of glider A. Strobe photography is used to record successive positions of glider A at 0.1 second interval, over a total time of 2 seconds, during which time it collides with glider B. So the following diagram represents the data for the motion of glider A. Positions of glider A at end of each 0.10 second interval are indicated by the symbol caret. Against the metric ruler, the total elapsed time after each 0.5 seconds is also indicated. A. Determine the average speed of glider A for the following time interval. So from 0.1 to 0.3 seconds. First, you have to find positions. And by the way, the average speed is d over t. This d is the displacement, time is the time interval in that equation. So find the time 0.1 to 0.3 seconds and take a look at the displacement and the time interval. So you have 1 meters per second. Similarly, you can find 0.9 seconds to 1.1 second. So here's 0.9, here's 1.1. Again, you'll find the displacement and the time. So displacement and time, you have 0.6 meters. Lastly, again, find the time corresponding the time and the position. So 1.7 and 1.9, and find the displacement and divide by the time interval. You should have 0.2 meters per second. Next one, on the axis below, sketch the graph consistent with the data above. So here is the data you collected of the speed of the glider as a function of time for the 2 second interval. So let's take a look at this diagram again. So we know from 0 second to 0.7 seconds, the velocity is constant, and that velocity we have calculated is 1 meters per second. From 0.7, however, to about 1.3, we know velocity is decreasing because for each same time interval, the distance traveled is decreasing. So that time v decreases. And from 1.3 to 2, again, the speed is constant, and that speed we also have calculated, which is 0.2 meters. So here is the time interval, a summary of the time interval and the corresponding speed. Now we are ready to graph. From 0 to 0.7 seconds, we know the velocity is 1. Then from 0.7 to 1.3, we know it's decreasing. So we don't know how it decreases. We just know it goes down. Then from 1.3 to 2, we know it's 0.2. So I graph this first. And this one is decreasing. So basically, you're trying to connect the smooth line, connect the 2 points. That's it. Next one, use the data to calculate the speed of glider B immediately after it separates from the spring. So the data we had before, that's only for glider A. So that's A speed before and after collision. This is before collision was 1 meters, right? This is during collision, the speed decrease. Then this is after collision. It is 0.2 meters per second. So to find B, we know initially it is 0. So we want to find velocity of B after. We use conservation of momentum. PB before equals P after. Before is just MAVA plus MB times 0 because MB is at rest. That equals to the mass of A times velocity of A after plus mass of B times velocity B after. Now you simply substitute your numbers and solve. So VB, you should have 1.2 meters per second. Next one, you're going to graph the speed of glider B as a function of time. It's very similar to glider A, so you know initially B is at rest from the same time from 0 to 0.7 seconds. This is when glider A before it hit B. 0.7 to 1.3, this is the collision. 1.3 to 2, this is after collision. So you know before collision, B is 0. After collision, B is 1.2 from 1.3 to 2 seconds. Then here, B speed should increase. You connect a smooth line, connect the 2 points. That's that. So now here is a graph of total kinetic energy of the two glider system over 2-second interval. Has following shape. K naught is the total kinetic energy of the system at time t equals to 0. As you can see, K is constant because object A is moving at a constant speed. This is during collision time. Then this one is after collision time. So first of all, is the collision elastic? Justify your answer. Let's see, what is elastic collision? What's the definition of elastic collision? The definition of elastic collision is the total kinetic energy is conserved. The total kinetic energy before equals total kinetic energy after. Therefore, the collision is elastic because according to the definition, total kinetic energy is the same. Next one. Briefly explain why there is a minimum kinetic energy at a curve equals to 1 second. What happened over here? Why is kinetic energy minimum here? So let's see what happens at t equals to 0. This is A is moving toward B. The two is sticking together at t equals to 1 second. The spring is compressed the most. And at t equals to 2, the two objects separated again. So this is when the two are moving together. At this point, all the kinetic energy is most kinetic energy is converted into elastic potential energy. That's why. So at time t equals to 1 second, the maximum kinetic energy is converted into elastic potential energy in the spring. So that's the reason why there is a minimum kinetic energy at t equals 1 second. Okay, that's it. I hope it helps. Thanks for watching.